All right, so this is Geometry, Chapter 1, Section 5, Angle Relationships. And before we get started with the examples, I want to give you guys some vocabulary. So you might want to pause at some point and copy this stuff down. We're just going to go over it really quickly here. First up is adjacent angles. Adjacent angles are two coplanar angles that have a common vertex and a common side, but no common interior points. So coplanar means that they're both in the same plane. So obviously everything on the board right now is in the same plane because the board is the plane. Common vertex, all of these have a common vertex, common vertex, common vertex. This one is not a common vertex, which is why it's a big fat no. Common side, so when I look at angle 1 and angle 2, they have this common vertex here. This is their common side, so they're adjacent angles. There's nothing in between them that is in common. So this is an example of what does work. This also works. Again, common side here. Nothing overlapping, that's totally okay. Over here on the right, we have some examples of things that don't work. We already talked about this guy. This one doesn't work because angle 3, which is this angle here, and angle ABC, which is this angle here, this angle right here, these two angles do not have a common vertex, and that's why it fails. This guy, you might be thinking these two angles are in fact adjacent, but when you read the writing over here, we're not talking about these two angles. We're talking about angle 3 and angle ABC, which is the bigger angle there, that's ABC. So angle ABC and angle 3 are not adjacent because they do have a common vertex, they do share BC as a common side, but you can see there's some overlap between, all of this space in between here is overlap between the two angles, and we can't have any common interior points. So any point here would be common to both angles, so that's why that fails. So then we move on to linear pair, and a linear pair is a pair of adjacent angles, so they are going to have a common vertex, common side, but the non-common sides are opposite rays. So here we have an example of two adjacents, common vertex, common side. The two sides of the angles that are not common, being this side here and this side there, are opposite rays, so they're going in opposite directions, so that's a linear pair. And over here on the right we have something that fails. And in this case, we have angle ADB, and angle ADC. So these two here, they are adjacent angles. They have a common vertex, common side, but their non-common sides, which would be this side here and this side there, are not opposite rays, and therefore this fails to be a linear pair. And then we have vertical angles, and vertical angles are again non-adjacent angles. So you don't want 1 and 4, or 4 and 2, or 3 and 2, or 1 and 3. You don't want adjacent angles, but vertical angles are formed by two intersecting lines. So here's this line and that line, they're intersecting. And so angle 1 and angle 2 would be considered vertical angles, these two here. And angle 3 and angle 4 are vertical angles, but again, non-adjacent ones. So over here we have what doesn't work. And the reason why this doesn't work is because AEB, which is this angle here, call it angle 1 if you want, and DEC over here are not formed by two intersecting lines. You have one line here, line AC, but line BE would actually keep going this direction, and so this one is not part of that line. So that is why that fails there. So then we have our first example. It says name an angle pair that satisfies each condition. It wants two acute adjacent angles. Now there are several adjacent angles on here, and let me just kind of clear up my board here. Oops, I didn't want to do that, but oh well. Okay, so basically in your book, this diagram is going to have a bunch of cheerleaders in it, you know, with their little pom-poms, but I didn't want to draw in the cheerleaders, so I drew in the parts that mattered. Adjacent angles, you know, less than 90, so we've got HJK is an acute angle, MJN is acute, this is acute, that's acute, this angle in here is not, this angle in here is not acute, and so on and so forth. So we don't want just acute, we want them to be next to each other, adjacent angles. So there's a couple of different options that you can use, but I'm going to go ahead and say LJN, so angle LJN, and then the next one is going to be this angle in here, which is going to be MJN. My little angle symbol there, MJN. So again, you could have picked this angle and that angle, or this angle and this angle, but you can't really pick this one and this one. because this is acute and this is obtuse, acute and obtuse, so really those are the only choices you have. But there you go. And then they want us to find two obtuse vertical angles, and the only vertical angles that you have here are the ones that you can see marked by this X right here that I kind of drew in. It's the black part of the diagram. And these two angles are vertical angles, but they are acute vertical angles, and they're asking for obtuse vertical angles. So it's very important that you go from here all the way to there. So you don't want to go from here to just there, if that makes sense. This one would not be a vertical angle. It has to be two lines. So you want to go from here all the way to there, and that would be HJM. So angle HJM. And your other one on the other side would be KJN. KJN. All right? Now, using the same diagram, and if you want, you can look in your book. I think it's on page 47. That's fine as well. You can do the same idea with these things here. A and B, same diagram, just different conditions that we're looking for. All right. So then we're going to go to our angle pair relationships. And we have a couple of relationships among pairs of angles. Okay? So first of all, we have that vertical angles. We talked about them earlier. Vertical angles are always congruent. So now they're not necessarily congruent to each other, but one pair is congruent. In other words, you can see by the arcs that are drawn here, this angle ABD is congruent to CBE because they have a matching number of arcs. There are 2 arcs and 2 arcs. So those 2 angles are congruent to each other. So that's what that says here, ABD and CBE. But also ABC and DBE, or EBD if you want to call it that way, are also congruent. But now this angle and this angle are not congruent to each other because they don't have matching arcs. So this one has 1 arc, 1 arc, 2 arcs, 2 arcs, 3 arcs, and 3 arcs, and on the story will go. Vertical angles are always congruent, but not necessarily all of them, just the vertical angles. Okay, so complementary angles. You might already know what this means, but I want to just make sure that everyone knows. Complementary angles are basically when 2 angles have measures that add up to 90. Okay, so again, over here we have an example. These are both examples of how you can have complementary. You can have 2 angles that are adjacent. So angle 1 and angle 2 are complementary because you see the little symbol there for 90. So they're going to add up to 90. Or you can have 2 separate angles that are not adjacent, but still have the right measures to add up to 90. This is 65 and 25. Obviously that adds up to 90. So sometimes you can say that instead of saying angle A and angle B are complementary, because the angle A is complementary to angle B. So they have that, and then of course we have supplementary angles. Same idea, only this time we have them adding up to 180. So here we have an example, angle 3 and angle 4 add up to 180 because it forms a line. We know that 180 degrees forms a line here, so those 2 angles are supplementary. Also, you can have a case where they're separated, but 120 and 60 adds up to 180, so angle P and angle Q are also supplementary. And another thing to think about that people often forget is that when you have a linear pair, a pair of angles that forms a line, kind of like this example here and this example here, that those angles are all supplementary. So in this case, the measurement of angle 1 plus the measurement of angle 2 equals 180 because these 2 angles are adjacent and they form a line. That's important to note. All right, and now we have our next example, and it says find the measures of 2 supplementary angles if the difference in the measures of the 2 angles is 18. All right, so what we're going to do here is we're going to say that we're going to use some algebra. So get your algebra hats on. So what we're going to do is the supplementary is first part. We have 2 supplementary angles. So I'm just going to call them A and B. So I know that the measurement of angle A plus the measurement of angle B is equal to 180 because that's what it means to be supplementary. That the 2 angles have measures that add up to 180. But at the same time, it's telling me that the difference in the measures of the 2 angles is 18. So difference means subtraction. So usually when we list A and B, we go smallest to biggest. So that means that the measurement of angle A minus the measurement of angle B is 18. So we know that when we add them together, they should add up to 180. And when we subtract them, they should add up, they should subtract to 18. Their difference should be 18. So we have 2 separate equations. But luckily in Algebra 1, you already learned how to solve a system of two equations. You can use elimination or you can use substitution. I will tell you that I think elimination is a lot easier, but what you'd have is two equations. And you might remember from Algebra 1 that when you do elimination, you add the two functions together. We just studied this earlier this year, so I'm hoping that you'll remember. We add the two equations together. We want to make sure that they cancel. If they don't cancel, you have to multiply one of the equations by something. But in this case, we already have a positive and negative, and so they match and they're going to cancel. So when we add these two together, they're going to go away, and we're going to get two measurements of angle A. And 180 plus 18 is going to be 198. Then we divide by 2, and it turns out that the measurement of angle A is going to be 198 divided by 2, and I'm going to look for my calculator here. I think my son stole it, but I'll borrow someone's from here. So 198 divided by 2 ends up being 99. So the measurement of angle A is 99. Once we know that A is 99, you can use any one of the original equations to find the next one. Obviously, we know that they have to add up to 180, so you can just very simply go 180 minus 99 and get 81. So if the measurement of angle A is 99, then the measurement of angle B would equal 81, and that would be our answer for our two angles where the sum adds up to 180, but the difference adds up to 18. And so you get basically 81 and 99. It doesn't matter which one of these says A or B, but that is how you do that. So now you can try this guy on your own, and then we will see how you do. Meanwhile, we're going to go on to some properties of perpendicular lines. So I have a diagram for you on the right. Hopefully you know that the upside down T right here represents perpendicular. So what we're saying here is that line AD, so this line AD is perpendicular to line BC. That is indicated on our diagram by this squarish red box here. And so we have about 4 things that you need to know about perpendicular lines. One, the first bullet, perpendicular lines intersect to form right angles. So when they're perpendicular lines, they form right angles. Also, perpendicular lines intersect to form congruent adjacent angles. So just because I only have a box here doesn't mean anything. We know that because this and this are vertical angles, then these are also 90. And since this is a linear pair, they have to add up to 180. So 90 and 90 would add to 180. And then those are vertical angles. So again, you get a bunch of 90-degree angles. So not only is this one 90, all of these are 90. Okay. Thirdly, so we know that perpendicular lines, segments and rays can be perpendicular to lines or other line segments, or even rays themselves. So it doesn't have to be a line. You can have a segment perpendicular to a ray and vice versa. And lastly, the right angle symbol, which is this little box thingy in the figure, indicates that the lines are in fact perpendicular. And of course, my symbol that means perpendicular. So here we go. We're going to apply some algebra to this concept. So we know, it says here, find x and y so that line PR, which is this big line here, and SQ, which is this line here, are perpendicular. Now we just said that in order for that to happen, all of these angles have to add up to 90. So this has to be 90, this has to be 90, this has to be 90, and these two combined have to be 90. All right, and that kind of basically helps us figure out what to do. So I'm going to go ahead and start with this bottom because I have to add those two together to equal 90, and they both have the x variables. So we're going to say 2x plus 5x plus 6 should equal 90. And again, I hope that you understand that that's because these two adjacent angles should add up to 90. They are complementary based on the diagram. 2x plus 5x is 7x. We move the 6 over, and we're going to get 84. All right, and then we are going to divide the 84 by 7 and get that x equals 12. So the x value that has to happen here is that x has to be 12 in order for this to be 90. All right? And now, the other thing that we can do, the other part of this is this y value. So we know that 4y minus 2, which is what is in this area here, also has to equal 90, because that would mean that it was a right angle. And so we solve the problem very simply. Add 2 to both sides, and then divide 92 by 4, and we're going to get 23. So the values that will make PR, line PR, and line SQ perpendicular are x equals 12 and y equals 23. So now you can try this little guy, and then we will go on to interpreting diagrams. And this is going to be interesting. I do want you to draw the diagram, but as far as what you're going to write, it's going to be a lot of stuff. So we just want to make sure that we know what you can and can't assume from looking at a diagram. Okay, so I'm going to tell you some things that you can assume from the diagram. All right, one thing that we can assume is that all these points are coplanar. They are all on the board, so they're all on the same plane. That can be assumed. We can also look at the diagram and know that point G, H, and J are collinear. There's no reason why we can't assume that G, H, and J are all in a line, so they're collinear. We can also assume that ray HM, so here's ray HM, ray HL, ray HK, and line GJ, so all of these three rays and this line intersect at point H. That is obvious from the diagram. We know also from the diagram that H is between G and J. You can tell that H is in the middle of G and J. Point L, is in the interior of MHK. So here's MHK, and point L is on the inside of the angle. Angle GHM, this angle right here, and MHL are adjacent. Okay? Also GHL, so here's GHL, this big angle right here, GHL, and LHJ are a linear pair because they form a line. And then of course JHK, angle JHK, and also KHG. So this big angle from there to there and this angle together are supplementary. They're also a linear pair. They also form a line. And that's just some of the stuff that you can assume just from looking at the diagram. And that's the easy part. You might be thinking to yourself, oh, that's obvious. The part that's not so obvious, that gets people in trouble all the time, is assuming things that aren't in the diagram. For example, you might be looking at this diagram and you might be thinking that HM, which is this guy here, and that HL, or I'm sorry, you might be thinking that HG and HL are perpendicular. But you cannot assume that from the diagram because there is no little red box indicating that they are actually perpendicular. So you cannot assume that. Congruent angles. You might be looking at some of the angles and thinking that maybe GHM and JHK look like they're the same size. Or that maybe this angle and that angle look like they're the same size, and maybe they're congruent. But again, congruent angles have to be marked with those little arcs that match up. One arc for this one arc for that one, 2 and 2, or whatever. And this diagram has no arcs, so we cannot assume any congruent angles. Furthermore, we cannot assume any congruent segments. Because again, if segments were congruent, you would have congruent segment markers. If angles were congruent, you would have congruent angle markers. If right angles were present, you would have right angle markers. Without any of those markers, you cannot assume congruent segments, congruent angles, or right angles. So just keep that in mind as we move on to this guy where we have a diagram over here. And this diagram does include some markers, so we're going to see what we can do here. But it says determine whether each statement can be assumed from the figure and then explain. A, can angle KHJ, so here's KHJ, and GHM be complementary? No, we cannot assume that. Okay, now why not? Because we have no reason to believe they're actually going to add up to 90. Okay, we know that this is 90, this angle in here, and we know that these other three angles should add up to 90, and I know that because this is a linear line, so all of these angles should add up to 180. If this one is already 90, then these other three angles that are left should also add up to 90. But if they're going to add up to 90, then these two cannot add up to 90 together. So even though the diagram shows that they're congruent, it doesn't mean that they're actually adding up to 90. So for part A, that's the answer no, and the reasoning behind it I just explained. So there you go. Now, what about B? Angle GHK and JHK are linear paired. So we're looking at GHK, GHK. That would be, now be very careful that you follow the letters G to H to K. That would mean this entire angle, and JHK is this angle. Yes, they are a linear pair. All right, because they form a line. Part C is ray HL, which here's my ray HL. Is it perpendicular to HM? To ray HM? Yes, the marker indicates that yes, it is. So out of these three, we had one no and two yeses based on the diagram. And now you can do these last two for do-it-yourself number 4. Alrighty? And I believe that that is the end of this lesson. So once you have answered those two questions that are A and B, then you will have completed your notes for this lesson, and I will see you in class. Thanks for watching.